Okay, first let's try to draw a diagram to illustrate the situation here. So we can start by letting A be the origin. This seems a little easier to construct the diagram. And letting two sides of the rectangle be along the coordinate axis. Again, this makes a lot of coordinates in the problem equals to 0, and zeros are easy to deal with. So we know AB equals 8, so B is here, whose coordinate is 0, 8. And C is here, D is here. C has coordinates 12, 8. D has coordinates 12, 0. Then have X here, whose coordinates is 0, 7 over 3. Y is here, whose coordinate is 12, 1. XY is here, AC is here, which meet at point P. So in this diagram, we have labeled the points A, B, C, D, X, and Y. Now, if we can find the coordinates of point P, then we can use the distance formula to find BP, right? We know that P is on AC because line AC has slope equals 8 minus 0 over 12 minus 0. This is 2 over 3. And it passes through the origin. The equation whose graph is AC then is y equals 2 over 3x, right? Point P is also on x, y. Then we find the slope of line xy, which is 1 minus 7 over 3 over 12 minus 0, which gives us negative 1 over 9. And its y-intercept is 0, 7 over 3. So we have line xy's equation. Y equals negative 1 over 9x plus 7 over 3, right? Rearranging this equation gives us x plus 9y equals 21. So this is the equation of line AC. This is the equation of line xy. P is the intersection point of the two graphs. So we could combine these two equations. Y equals 3 over 2x. Then x plus 9y equals 21. This can help us to solve x and y, right? Which is x equals 3 and y equals 2. You get it? And then point P has coordinates 3, 2. And point B has coordinates 0, 8. Then we have BP equals square root of 3 minus 0 squared plus 2 minus 8 squared, and eventually this gives us 3 square root 5. Do you get it? Alright, if no questions, let's consider the next question. In triangle ABC, we have AB equals BC equals 8, and angle ABC equals 45 degrees. Can you find the length of AC? Okay, let's have a look at the solution here. So we could make use of analytical geometry to help us solve this problem. The 45 angle makes us think about analytic geometry because the graph of the line y equals x makes a 45-degree angle with a coordinate axis, right? We also notice that AB equals BC equals 8. That means A and C are both on the circle with center B. Oh, sorry. This should be C here. And radius 8. In other words, if we let B be the origin, and then the coordinates of A and C are the solutions to the equation x squared plus y squared equals 64, right? So if we let BC be on the x-axis, and this is our y-axis, we know B has coordinate 0, 0. Because the graph of this equation is a circle with center 0, 0 and radius 8, we know the graph of y equals x makes a 45 degrees with the axis. So we let C be along the x-axis. So C has coordinates 8, 0, and then A be on the graph of the line y equals x. So this is the line y equals x, right? So we can then find the coordinates of A by using our equation for the circle. Because A is on both the circle and the graph of y equals x, we can find the coordinates of A. Because A is on the line y equals x, so we can let the coordinate of A be x, right? So we know that x squared plus x squared equals 64. This gives us x squared equals 32, and then x equals 4 square root 2. We only use a positive 4 square root 2 here because according to our establishment here, A has positive x coordinate. So x must be positive. and therefore A has coordinates 4 square root 2, then 4 square root 2, and we can use the distance formula to find AC, right? AC is square root of 4 square root 2 minus 8 squared plus 4 square root 2 minus 0 squared, and this is 8 square root of 2 minus square root 2. Did you get it? Okay, if you don't have any questions, let's consider another problem. Can you find the distance between the point 2, 7 and the graph of the line x minus 3y equals 1? Okay, first let's try to draw a diagram to find the point and the line. Again, not necessarily to scale. The line has the equation x minus 3y equals 1, which means it will pass the point 0, negative 1/3, and 1, 0, right? So it's a line like this. Okay, let's call this line is K, and we have a point 2, 7, which is somewhere here. Let's call this point P. Okay, we let Q be the point on K that is closest to P, and PQ is the distance between the point and the point and the line K, right? Okay, first of all, if you want to find the distance of PQ, it's better find the coordinates of Q, right? We know the slope of line PQ. Okay, first of all, let's rewrite this equation in the slope-intercept form. This is 3y equals x minus 1, which is y equals 1/3 of x minus 1 over 3. And we know the slope of line PQ is negative 3, right? Because PQ is perpendicular to K. And We also know the equation of line PQ is, well, now we know the slope. We know a point on the line, so the line has equation y minus 7 equals -3 times x minus 2, right? And rearranging this gives us 3y plus y equals 7 plus 6, which is 13, right? So that's the line PQ, and this is the line K. And then we can use the point of intersection between K and PQ to find the coordinates of Q, right? Combining these two equations will give us the coordinate of Q. So solving this equation gives us x equals 4 and y equals 1. Therefore, we know Q has coordinates 4, 1, right? Then we can find the length of PQ, which is square root of 2 minus 4 squared plus 7 minus 1 squared. This gives us 2 square root 10. Did you get it? And actually, this can be generalized. If P has coordinate x0, y0, and the line has equation ax plus bx plus c equals 0, then you can also find the distance between the point and the line. So the generalization gives us the following important conclusion here. So I'm not gonna prove this for you. You can try to do this by yourself. It tells us that find the formula. If you can find the solution of this problem, then we have the following important conclusion. The distance between the point x0, y0, or x0, y0, and the graph of the equation ax plus bx plus c is 0 is always given by this expression, which is the absolute value of ax0 plus by0 plus c divided by the square root of a squared plus b squared. Are you clear? Alright, if you don't have any questions, let's consider another question. How many ordered pairs x, y satisfy both 14x minus 48y plus 49 equals 0 and x squared plus y 0 equals 1? Okay, let's consider solution of this problem. So how many ordered pairs x, y satisfy both of the two equations? In other words, this question really asks us how many point of intersections between the line. We know the equation, the graph of this equation is a line, right? And the graph of this equation is a circle. So in other words, it really asks you how many points of intersections between this line and the circle. So how could we determine how many points of intersection between a line and a circle? We could check the distance between the center of this circle, which is 0, 0, and to the line, right? If the distance between the center of the circle to this line equals the radius, then we know the line is tangent to that circle. Or if the distance between the center of the line is larger than the radius, then the line will never touch the circle. Otherwise, there will be 2 points of intersections, right? So according to the formula we have just learned, we need to check the distance between this point 0 and 0 and the line. The line has equation 14x minus 48y plus 49 equals 0, right? So we can use the formula we have just learned. Distance is absolute value 14 times 0 minus 48 times 0 plus 49 over square root of 14 squared plus negative 48 squared, and this will give us 49 over square root of 14 squared plus 48 squared. And this gives us 49 over 50, right? So the distance between the center of that circle to the line is actually less than the radius of that circle. Then we know the line goes inside the circle, right? Which means it will intersect the circle twice. And this tells us that there are 2 ordered pairs. That satisfy both of the given equations. You get it? Okay, then sometimes we could also use analytical geometry to prove important properties. So, for example, let's consider this question here. Use analytical geometry to prove that the midpoint of the hypotenuse of any right triangle is the circumcenter of the triangle. So suppose we have a triangle, right triangle ABC, and actually we can choose any point to be the origin, right? So we choose one of the vertices of the right angle to be our origin. For example, we could establish our Cartesian plane like this. C be the origin point. A has coordinate A0, B has coordinate 0B, C has coordinate 0, 0. Since C is the vertex of the right angle, side AB is the hypotenuse, we let M be the midpoint of AB. So we have coordinate of M is A over 2, B over 2, right? To show M is the circumcenter of triangle ABC, we must show that M is equidistant from all three vertices. And this is job for the distance formula. We could find the distance between A and M. AM equals A over 2 minus A squared plus B over 2 minus 0 squared, and this gives us square root of A squared plus B squared over 4. You could also check distance between B and M, which is square root of A over 2 minus 0 squared plus B over 2 minus B squared, and this is still square root of A squared plus B squared over 4. And then let's check CM, which is square root of A over 2 minus 0 squared plus B over 2 minus 0 squared, and this is still A squared plus B squared over 4. And therefore we have AM equals BM equals CM. So M is the circumcenter of triangle ABC. Also notice that every step in our proof is valid even if A or B or both are negative. Okay, then let's consider another problem. You use analytical geometry to prove that the midpoint of the hypotenuse of any right. Oh, sorry, we have just solved this, right? So let's consider another one. Use analytic geometry to prove that the median of a trapezoid is parallel to the basis of the trapezoid, and that the length of the median is average of the length of the basis. Alright, so suppose we have a trapezoid like this. W, X, Y, Z. And we could establish a 2D Cartesian plane like this. We use W as our origin point. So W has coordinates 0, 0. X has coordinates A, 0. And suppose Y has coordinate B, D. And Z has coordinates C, D. And the midpoint of leg WZ, let's call it M, must have coordinates C over 2, D over 2, right? and midpoint of yx has coordinates a plus b over 2 and d over 2. The median connects these 2 points, so the median is on the line y equals d over 2. Therefore, the median is horizontal, so it's parallel to the basis. We can also use the coordinates of the midpoints of the legs to determine that the length of the median is a plus b over 2 minus c over 2, which is a plus b minus c over 2, right? The lengths of the bases are wx equals a and yz equals b minus c. So the average of the length of the bases is also a plus b minus c over 2, right? So these two values are equal, which means the length of the median equals average of the length of the bases. Also notice that every step of this proof is valid for all other arrangements. Any questions? Alright, then next let's have a look at some other question here. Okay, so analytic geometry is so useful that we can use it to prove some other complex problems. So I'll leave this question for you to prove after this class. See if you can do this using analytic geometry to prove that the medians of any triangle are concurrent. Any questions, just let me know, okay? Alright, last, we're going to have a look at some advanced analytic geometry problems. Okay, first question. Find the area of the region bounded by the line 2x plus 3y equals 21 and 5x plus 2y equals 25 and the coordinate axis. Okay, first of all, let's try to find the location of these lines. The first line must crosses the point 0.7 and then 10.50. This is the first line, right? So let's call it L1. The second line passes the point 0.25 over 2, which is around here. And then five zero, which is somewhere here, right? So this is the line L2. And we're trying to find the area bounded by these two lines, and the coordinate axis, which is here. And let's call this point P, and this point is Q, R, and S. So PQRS is a quadrilateral, but it's not one of our special types of quadrilateral, so it's not immediately obvious how to find area of this shaded region. Therefore, we use a tactic from our study of funky areas. We can divide the shaded region into pieces we know how to handle. We can draw the diagonal PR, which cuts the shaded region into two triangles. Because we can easily find areas of triangle PQR and PRS, right? So the graph of 5x plus 2y equals 25 intersects the x-axis at point Q. We already know point Q has coordinates 5, 0. And next we could easily find the point of intersection between these 2 points, these 2 lines. At point R. This gives us x equals 3, y equals 5. And therefore we know R has coordinates 3 and 5. S has coordinates 7, 0, 0, 7. P has coordinates 0, 0, right? Okay, so this gives us the area of triangle PQR equals 1/2 times 5 times 5, which is 25 over 2. And triangle PSR equals 1/2 times base 7 times height 3, which is 21 over 2, right? And therefore we know the area of PQRS equals the area of triangle PQR plus the area of triangle PSR, and this gives us 25 over 2 plus 21 over 2, and eventually this gives us 23. Do you get it? Alright, if no questions, let's consider another problem. What point is the image of rotating the point -1 straight on an angle of 180 degrees about another point -6, -7? Okay, let's have a look at the solution together. Okay, -1, 3 is probably here. Let x be the point -1, 3. And we have another point, -6, -7. And it's probably somewhere here. Let y be -6, -7. And the image of rotating the point x on an angle of 180 degrees about and point y is somewhere here. So let's call this point B Z. Because the angle of rotation is 180 degrees, we have angle XYZ equals 180 degrees, right? So point Y is on segment XZ. Furthermore, because Z is the image of X upon rotation about Y, we have XY equals YZ. Since Y is also on segment XZ, we know that Y is the midpoint of XZ. So if we have the coordinate of Z is AB, we have A plus -1/2 equals -6, and B plus 3/2 equals -7. And therefore we have A equals -11, B equals -17, right? So the image of Z upon 180 degrees rotation about Y is -11, -17. Did you get it? Okay, if no questions, let's consider another rotation problem. What point is the image of rotating the point 4, 5 at an angle of 90 degrees clockwise about the point -4, 2? Okay, let's have a look at the solution together. So first of all, let's find the point 4, 5. Suppose this point is here, which is A. Another point is -4, 2, which is about here. So point B, -4, 2. And our job is to rotate A about the point B for 90 degrees. This is probably somewhere here, right? And we have a 90 degrees here. And this is point C. Okay, so in order to find coordinates of C, we could construct a right triangle like this. And then construct a right triangle like this. So if we consider these two right triangles, we know this angle plus this angle equals 90 degrees, right? And this angle plus this angle equals 90 degrees. So this angle here equals this angle. And both of these two angles are right angles. We also know AB equals BC, right? So according to AAS, we have two congruent right triangles. So let's call this point Y and call this point X. So we know that AX should equal YC, right? The length of AX equals length of YC. The length of BX should equal the length of BY, right? So first of all, we know coordinate of X is 4, 2. The coordinate of Y is -4. Well, if by equals bx, bx is 8, then we know the y coordinate of y is 2 minus 8, which is -6, right? And we also know that if yc equals ax, we know ax equals difference between the y coordinate of a and x, which is 3. Then we know yc must equal 3. So c is to the right of y by 3 units. So x coordinate of c is -3 plus -4 plus 3. So that gives us -1, right? The y coordinate of c equals y coordinate of y, so that's -6. Therefore, the desired coordinate of desired point C is -1, -6. Did you get it? Alright, if no questions, let's consider another one. What point is the image of reflecting the point 5, -3 over the line y equals 8? Okay, first let's have a look at the line y equals 8. So this is a line y equals 8, right? And the point 5, negative 3 is 11 units below that line. It's probably somewhere here. So the point 5, negative 3 is 11 units below the horizontal line y equals 8. So its image is 11 units directly above y equals 8. Therefore, the image of 5, negative 3 upon reflection over the graph of y equals 8 is somewhere here with coordinates 5, 8 plus 11, which is 5, 19, right? Also, we can quickly check this by noting the graph of y equals 8 is a perpendicular bisector of the segment with endpoints 5, 19, and 5, negative 3. This tells us that 5, 19 is the image of 5, negative 3 upon reflection over the graph of y equals 8. Okay, if no question, let's consider another one. What point is image of reflecting the point 3, negative 1 over the line 2x minus y plus 5 equals 0? Okay, so first of all, let's find where is this line on the coordinates. First of all, we can convert it to a slope-intercept form. So this line is y equals 2x plus 5. And this will help us to see where this line is. When x equals 0, y equals 5. And when y equals 0, x equals negative 2.5. It's probably somewhere here. So let's call this line L or K. Okay, this is line K. And the point is 3, negative 1. So 3, negative 1 is somewhere here. 3. Okay, 3, negative 1 somewhere here. And point of image of that point is somewhere here. So let's call this original point is P. And image is R. Point of intersection between RP and K is Q. So because R is image of P upon reflection over K, segment PR and K are perpendicular, right? The slope of K is 2, which is here. Then the slope of PR must be -1/2, right? Because their product must equal -1. Therefore, R is on the line through P with slope -1/2. Then a point slope form of this line equation is y minus -1, which is y plus 1, equals the slope is -1/2 times x minus 3. So we can try to rearrange this by multiplying both sides using -2. And this gives us x plus 2y equals 1, right? So this is the equation of line PR. And in order to find the point of intersection Q, we could combine the equation of K and PR. The reason we want to find the coordinates of Q is the midpoint of R and P. So if we know the point coordinates of Q, coordinates of P, then we can find the coordinates of R, right? So line K has equation 2x minus y plus 5, or 2x minus y equals -5. Line PR has equation x plus 2y equals 1. And this tells us that 2x minus y equals -5, then 2x plus 4y equals 2. Then we have 5y equals 7, which means y equals 7/5, and then x equals -9/5, right? Therefore, we have Q has coordinates -9/5, then 7/5. So if we let the coordinate of R be xr, yr, then we have xr plus 3 equals 2 times -9/5. This gives us xr equals -33/5. And then 7/5. Oh, sorry. And then yr plus -1 equals 2 times 7/5, and this gives us yr equals 19/5, right? So this is x coordinate and y coordinate of the reflection point R. Therefore, the desired point R has coordinates -33/5, +19/5. Any questions? Alright, if no questions, because of time constraints, I'll leave the last two practice questions for you to solve after this class. If you have any questions, just let me know, okay? Okay, first question. Medians XA and YB of triangle XYZ are perpendicular. If angle YXZ equals 90 degrees and XY equals 8, find YZ. Have you written this down? Okay, second question. A point P lies in the same plane as a given square of side 1. Let the vertices of the square taken counterclockwise be A, B, C, and D. Also, let the distance from P to A, B, C, and P to A, B, and C respectively be U, V, and W. What is the greatest distance that P can be from D if U squared plus V squared equals W squared? Alright, if you have written this down, then class dismissed. I'll see you next time. Bye.